So today is the 13th day of the May LeetCode 30-day challenge, and the problem will be remove k digit. So we are given a non-negative integer now represented as a string, and we are asked to remove k digits from the number such that the new number is the smallest possible. And before we dive into the solution, there is an idea that can help us solve this problem. So the idea here is, suppose we are given some numbers, say for example 2, 5, 4, 3. How do we form the smallest possible number? The idea is we should put the smaller number as close as to the most significant bit and the larger number as close to the least significant bit, so as we can minimize the impact of the bigger number. Say for like this one, 1, 2, 3, 4 to 9. So if we are given from 1 to 9, then the overall best result will be 1, 2, 3, 4, 5, 6, 7, 8, 9 for the smallest possible number, because once we put 9 into the front or just 4 into the front, we will not get as smallest as possible because the larger number has not put impact to the most significant bit. And here is how we solve this problem. In this problem, we will basically use the idea called monotonic stack. A monotonic stack is a stack that from the stack base to the stack top, the number will be either in increasing order or in decreasing order. So that will be in a monotonic manner or monotonic fashion. And in this problem, we can use a string instead of a stack, because the string pop back is similar to the stack pop, and string back is similar to top, and string provides us some very good useful things to do these operations. So let's see how this work. So now k is equal to 3 and number is 1432219, same as the example from the problem. So now the first one will be pushed back in it, and then we have the current number 4. So because 4 is greater than 1, so 4 should be as close to least significant bit as possible. So the 4 will be pushed into it. 2 and 3, now we have 3. The current character is 3. However, 3 is greater than 4. And so what are we going to do now? We are going to pop all the stack element that is greater than current character, which is 3. And as we pop, we should decrease the k because we are asked to remove k digits from it. So now we pop 4 from it, and the stack top is this one. And stack top is now 1, but 1 is not bigger than 3, so we simply not remove 1 from it, and k will be decreased to 2, and finally we push 3 back. And here we have the same situation, that 2 is lesser than 3, so we simply compare 2 with 3, and 3 will definitely be popped out, and k will be decreased to 1. So here we have 2. And now we have another 2. Simply just push back. And now the character is 1. So 1 is lesser than 2. So we pop out 1, 2, and k is not decreased to 0. However, we cannot pop this 2 because we have already used out all the possible k. So there is no more room for us to pop the digit. So we simply push back the 1 here, and we simply push back a 9. So the remaining result will be in this one. One, and this 2, and this 1, and this 2, not this 2. This 2 has been popped out. 1, 2, 1, 9. So result will be 1219. And suppose k is not 3 now. Suppose today k is 4. What are we going to do? Because at that time, we can pop one more 2 from the string because we have 1 which is lesser than 2. So if k equals to 4, then these 2 will be popped out as well. And after we traverse from the number, or we iterate it over the string number, then we will definitely get a string which the most significant bit and the least significant bit. So the string is like this. The most significant bit will have the smallest number, while the least significant bit will have the biggest number. And they are in the monotonic order. So not in the ascending or in descending, but in the monotonic increasing or decreasing. And if k is now 5, because the string now is guaranteed to be the monotonic, so we can just pop more from the tail of the string, which is same as the stack top, to form the final answer. For example, now we have 119, and if k equals to 5, then we should pop one more from this string. And what should we pop? We definitely will pop the largest number as large as possible, so as to form the smallest possible number. And now we can finally jump to the coding part. Before we dive into the coding part, I have another example to show this idea. So in the second example, we have the leading zeros, so which is not allowed. So how do we solve this problem? And the leading zero will be simply like, we first push back 1, and now we have 0. The current character is 0. And if we pop 1 out and simply push 0 back, then we will definitely have the leading 0 as answer. So the answer will be simply just like 010, which is not allowed. So what are we going to do here? Before we push back anything into this resource string, then we should definitely check if the string is not empty, and the current character is not 0. So we are allowed to do this and to push back. And otherwise, if the string is empty and the current character is 0, then which means we will definitely put a leading 0 into it, and which is not allowed. So we can simply now start to the coding part. And the coding part is not so hard, as we have described how to solve it. We simply initialize the result and iterate it through the array or through the string. So if the current character is lesser than the top, or say the back of the string or top of the stack, and we still have the k can use, and we should check before we access that number. So we have to check the stack size first, otherwise we will get some runtime error. So simply we will decrease k and pop that number out. So result.pop back, and so we should only push back the number if this situation is not allowed. What situation? The situation is not allowed when the current character is at 0 and the result is empty, because this will cause the leading 0. So result.pushback character. And finally, because we have ensured that the string is in monotonically increasing order from the most significant bit to the least significant bit. Say here. Most significant, least significant bit, and the bigger number will be closer to the string's end. So we result size and k minus minus. We use the remain k and we pop the number which is larger, pop as large number as possible. So we pop back and we simply return result. And before return the result, we should check if the result is empty. It's not empty, we simply return result, otherwise return 0. And let's see how if this works. Okay, and thank you for watching today's video, and see you tomorrow. Bye bye.